The next loco that I'm going to convert to DCC is this 1970s Minitrix Class 27. These are pretty easy to disassemble, and the instructions I've seen online for conversion look fairly easy as well. So to begin with, it's just 2 screws on the top. Put that to one side. These screws are loose, so you just have to be careful not to lose them. There's a simple circuit board on top which has a very old style, I think, selenium diode for doing the lights. You just pop that out of the way. Underneath you've got the motor and then a worm gear at either end going to the bogie. All 8 wheels are driven. I'm going to take this apart in a minute. One of the things I'm going to do with this conversion is change out these grain of wheat bulbs, which are just a white, to give me a white and a red light at either end depending on the direction of travel. To get at the lower circuit board and the motor connections, you have to take these 4, let me move my hand out of the way, sorry. Take these 4 screws out. At this point, the motor should lift out. If it's reluctant to move, it'll be because the simple spline connection either end isn't quite lined up, so you might just have to wiggle it a little bit to get it to come out. There's a little spline at either end, and that has to line up with the spline on the worm gears. With the motor removed, the upper and lower circuit boards just come out together. It's worth noting that this tab here makes contact with the inside of the chassis, and that is the negative, or ground. This is the bottom side of the motor, and one of the things that I'm going to have to do is, at the minute, this spring, which is on one side of the bush, is isolated on one side but not the other. I now need to make sure I isolate this side so that the motor is only being supplied power from the DCC chip. Find a bit of insulation to put between this spring and the brush holder just there. Okay, so I found something that I think I can use. I've got some just a scrap of wire that I've been using and stripped off some of the outer sheathing there, and that looks to be the same size as the existing stuff. There we go. Now I need to reinstall the 2 motor brushes, and as you can see, there's insulation on both sides of the spring clip that holds them in place. The next step is to remove all of the components and wires from these 2 small circuit boards. The diode has quite a lot of solder and 3 points, so it'll probably take a few passes with the soldering iron and a solder sucker just to get that clear. But I'll take the little wires off first so the 2 boards are separate. What's going to be important to remember is that the wires that come down through this top board, on this side of the board there's no extra slot. On this side of the board there's the chassis connection, so I just need to remember that once I've taken these wires off. Okay, so you can see that the component's been removed. There's still quite a lot of solder on these pads, so I'll turn the camera off now and go and clean this up. So for my own, just reminding to myself, I'm going to write a front and rear on this board. The front is the end that has the extra location pin that matches up with the motor holder. Okay, and that's just so that I make sure I wire up the new LEDs the right way around. The components on the lower board, I think there's a choke and a capacitor, are there to reduce the amount of high frequency radio transmissions that come off the motor. This is all now handled within the DCC chip, so these components can be completely removed. And then, like the other board, I'm going to go through this now and just clean up any of the old solder. Right, before I move on to the next bit, we'd better just have a quick look at how the pickups work on this loco. So this loco, out of the box, comes with all-wheel pickups. On this side of the loco, there are pickups that rub on the back of the wheels. So on all of this side, we're going to take it that this is the front and that's the back. So the right hand side wheels pick up off the backs of the wheels, and these wheels are isolated. Let me just pop one of the bogies out so I can show you what I'm talking about. If you do this, just make sure you don't lose the gear out of the centre of the bogie. So on the bogie, you've got this little brass piece here, bronze piece, brass piece. That's connected to all the wipers that rub on the backs of the right hand side wheels. The left hand wheels are purely connected to the chassis, and so this whole chassis then becomes the common. So this is the lower plate, and these two end pieces are where the brass bushes, brass pickup bits rub. So what we need to make sure is that we completely isolate the motor from any of this section and any of the chassis, because the whole chassis is the other common. That's why we had to, on this one, add the extra bit of insulation for this brush, the brush spring. Now on the guide I was looking at online, this was already insulated, and this here, which pushes on the bottom of the motor, was isolated from this. Well, on this, that track on this circuit board is connecting the motor to the chassis, So I need to break this now. Then when I rewire it, I'm going to have my black wire going to this point, my red wire going to this point, my orange to this point, my grey to this point. I think I'll double check which way around they are. Now that we know that the right hand wheels rub on these, I'll try and make sure that my wiring is kind of correct to the standard that these are wired to. To break the trace on this board, I'm going to use a scalpel to cut this track, which is particularly difficult because there is still a load of solder on it. Right, I've now cut that track away, and I'm just going to double check it with a multimeter. Yeah, so there's now no connection between this part, which is going to be connected to the chassis, and this part, which is the motor. I do need to reattach the little chassis spring onto here, but I'll solder that back on when I solder the black wire to it. I also will put a small piece of insulation tape on it to make sure that the brass strip that makes contact with the motor can't make contact with this part. So while planning out how to fit the decoder socket in and the amount of wire I need, I've put the circuit board down. The 4 wires, the 2 pickup wires and the 2 motor wires, all need to go through this rear right slot. But because of the way the two because of the way that the body screws through the circuit board, the socket's going to have to sit here, which means I need to open up the slot here for the wires to pass through. So I'm just going to do that using some little needle files. Okay, so we're planning out where the decoder's going. In this loco there's loads and loads of room. If you can see, you've got these standoffs moulded into the body. All of that space in there is totally clear. So what I'm going to do is the decoder's going to sit on top of the circuit board. That circuit board represents where the bottom of those standoffs go. I'm going to have a little loop on the 4 motor and pickup wires, which will then fold flat. And then at the point it goes through the gap in the circuit board, I'm then going to measure off the length of the original wire and cut them to be about the same length, so that we haven't got too much wire in here. There's a little loop at the top, so should it be a little bit short, I'll be okay. Right, now I'll strip these and get them soldered onto the little board. So to route the wires, they're all going to come through the different holes in the bottom of the lower PCB. The black wire is going onto the chassis contact, and the grey motor wire is going on next to it. The red positive wire is coming into the centre, and the orange wire is going on here. I'm going to tin the 4 wires that they are going to be connected and the 4 points they connect to, and then just touch the soldering iron, and that will get them all soldered up. Now that the wires are all soldered onto the board, I'm going to carefully pull each of these wires through, route them and make sure they don't touch any of the other contacts. Okay, so I've now got the lower board pushed down into place with the wires routed towards the rear right. It's just important as we put the motor on top that none of these get trapped. The final step with the lower board is to make sure that the chassis contact and the motor contact can't touch. So with that I'm going to use some very thin insulation tape, just a small piece, to make sure that they'll remain isolated from one another. With the cables routed and the lower board in place, it's time to get the motor back. Make sure that the little spline bits are vertical and that the worm gears are vertical, otherwise it won't go in. It's also important to make sure you don't trap any of these 4 wires between the motor mounts and the chassis. Okay, on inspecting mine, the lower circuit board hasn't quite seated right with the motor mount, so I'm going to take it apart and try again. It's now got it this far. I've been and just tested it on my programming track. To begin with, it didn't work, and it took me a while to track down the issue, and it was actually on the pre-bought socket. One of the wires had a bad solder joint. Once I got that repaired, the DCC programmer was able to find that it was on channel 3, and then put it onto the main, turned it on, and it drove in both directions. It needs a good run in, but at least I know it's working, so I can continue with the rest of the conversion and then I'll run it in after we've finished. So once I've got it up and running, I then built a very small lighting kind of mini circuit board that has got a white and a red surface mount LED on it. These are then connected up, so the yellow terminal is the rear direction, and that's the negative of the red LED, and the white is the front direction, and that's the negative of the white LED. Then we've got the common blue, goes through a 1K resistor and is shared between the two. Now I'm going to have a go and build the same little circuit board to go on the front. I found the easiest way to hold this in for now. There's actually just 2 small pieces of blue tack behind the board. There's some space in the front, but if it's too high, the plastic from the windows would be effective. Just so happens that with a bit of strip board that's 6 pieces wide, LEDs between the first and second and the 5th and 6th strip, sorry, you can't see that very well, will be pretty much in line with the lights on the body. So I'm going to try and film it, but I don't think I'm going to be able to show you clearly enough because I can't get in close enough to show how it works. So the LEDs I'm using are absolutely tiny. They come in these packages, and I don't know whether you'll be able to see it all, but I've soldered one on. And then using my multimeter on continuity check, there's normally enough voltage just to light these if it's worked. Next I need to put a link between the outers and then the 1 kilo ohm resistor. So my feed from the decoder will come in, go through the resistor, and then link the two sides, and then the cathodes will be different, and that's how we'll get the two different colours to work. Then I'm just going to put these are actually offcuts from the decoder, so they're the right colour, we know the right thickness. Okay, so for the E-glide, you might have spotted that I'm soldering everything onto the copper face of the board and not having it through hole. That's because if you have a look on the one that I've already done, which won't be in focus, there's not enough room. If I put the components on the other side of the board, it sticks out too far. But since it's only a couple of little leads and a resistor, it's not too bad. With the leads attached, I'm now going to check again with the multimeter just to make sure that everything's working. So the red lead goes to the blue, and then when I touch on the white or the yellow, I should get the LED lighting up. So the white one's okay, the yellow one's okay. Since the Loco chassis originally worked as a negative terminal and is still connected like that, I need to make sure that the lighting board is isolated from that board. And to do that, I'm just going to use some Captain tape and trim it to fit. The other thing that I've already done on this Loco is to have removed the 2 grain of wheat bulbs that were there originally, because I don't need them anymore. And then I'm going to make use of the top circuit board, mainly just so that I don't have to have wires running the full length in blue, yellow and white, because it might get a bit messy, and the circuit board is already there. But to make use of the tracks, you need to cut the tracks at either end, because they originally pushed against the grain of wheat bulbs, which aren't there anymore. So you just have to make sure you cut the tracks so that the metal tabs don't connect to the new LEDs. What I have done is bend those metal tabs backwards slightly so that it just holds this circuit board onto the chassis a little bit easier. On this decoder I've got a blue positive for the functions, so what I've done is gone to the centre track, which isn't used on the original model. I believe that track's used on the same circuit board was used on a different model that had a pantograph. So I've just used that, and that gives me a track that runs front to back, doesn't touch any part of the chassis, so I can just put my blue lead at either end. The other tracks go the rear bulb and the front bulb. So what I've done is I'll connect all of the whites together. No, I won't. That's where I've got to be careful here. So when the Loco is in forward, that will energise the white LED, the white line. So I actually need to swap my 2 wires over on this little board so that when it selects the white line, the red LED turns on this end and the white on this end. Yeah, so I just need to change these 2 wires over so that they light the right LED. Otherwise I'd have 2 white LEDs lighting up and 2 red LEDs, and I want the opposite of that. Anyway, once that's done, the little circuit board sits there in the recess, and then all I'll do is solder the blue lead to that tab, the yellow lead to this trace, and the white lead onto this trace. So I'll do all of that now and show you with it all finished. Okay, so that little circuit board is in place, the wires are soldered on. I'm just going to tidy this up now with a bit of insulation tape, put the body back on, and then we'll go and test it on the little test circuit. So as you can see, the light works, and if I change direction, you can't see that it's red very well because it's too bright. All in all, I'm really happy with how this DCC conversion's gone. It's definitely easier than when I did the little panning tank.